Okay, we are on Algebra 1, Lesson 12.4, Multiplying and Dividing Rational Expressions. So we have two warm-up parts today. So I really want you guys to go ahead and do this before I show you how to do it. I want to make sure we know what we're doing. Okay, so on this first page, it says to multiply. So basically, we're going to distribute the front term back to all the parts that are inside. So 2x squared times x equals 2x cubed. 2x squared times 3, we have to have a plus, equals 6x squared. Okay, for this next one, we're going to FOIL, so we get 3x squared plus 7x. This becomes a minus 15x, and then a minus 35. And when we combine like terms, we get a negative 8x in the middle. So this is your final answer. Okay, for this next one, I'm going to distribute, so 3x cubed plus 6x squared plus 6x. And then for this last one, we need to simplify. Okay, for the 12 and the 40, I can take a 4 out of the 12, which 4 goes into 12 3 times, and 4 goes into 40 10 times. I can take away 5 of these, and I'll have 7 left. And then I can take away 10 of the ones in the bottom, and I'll have 5 y's left on the bottom. So that gives me a 3x to the 7th on top over a 10y to the 5th on the bottom. So that was that answer, that was that one, and then this one. Okay. Second part of the warm-up says to divide the fractions. Something we need to remember when we divide a fraction, it is the same thing as multiplying by the reciprocal. Multiply by reciprocal. And the reciprocal is just the flip. So 2/3 is the same thing. 2/3 divided by 1/2 is the same thing as taking 2/3 times 2 over 1. So I just multiply across, I get 4 over 3. For this next one, I'm going to multiply by 3 over 11. I will get 9 on top and 55 on the bottom. For the next one, 2 over 5, I'm going to multiply by 15 over 7. I can cancel before I do this. 5 goes into 5 one time, 5 goes into 15 3 times. So now I just have 3 times 2, which is 6 over 7 times 1, which is 7. Okay, 3/4 times 16 over 9. I'm going to simplify first. 4 goes into it 1, 4 goes into that 4 times, so I'm just left with 4 over 3. I suggest simplifying before you multiply so you don't have to multiply big numbers. So we're going to look at multiplying and dividing rational expressions today and how to simplify those. The rules for multiplying rational expressions are the same as rules for multiplying fractions. You just multiply the numerators and then you multiply the denominators. So how we just multiplied straight across, that's how we would do it. So for example, if I have a over b times c over d, I just multiply the a times the c and then the b times the d. You just multiply straight across. So let's try this one. So if I'm going to multiply, I'm going to take 4 times c over, or c minus 1, and then I'm going to take 2 times 3c minus 3. All right, so now I could actually multiply, distribute across, but I'm going to simplify first. I'm going to take a 2 out of here and a 2 out of here, and now I can just multiply. I'm going to rewrite that actually, just to make things easier. So I have 2 times c minus 1 over, I have a 1 in front, so it's 3c minus 3. Okay, looking at this denominator, is there a greatest common factor you can pull out? There is. You can pull out a 3, and you're left with c minus 1. Well, look at that. Those c minus 1s cancel, and we're just left with 2 over 3. Okay, so on this next one, they kind of wrote out the first step for you. They took 8 times 10, and then we're going to multiply the x's together, the y's together, and the z's. And then on our bottom, it's the 5 times the 16, and all of those parts multiplied together. Well, before we multiply, we can actually simplify things out. So for example, this 8 and the 16 can cancel. This 5 and this 10 can cancel. And then even from there, I've got a 2 and a 2 left. Those 2's cancel. So I can simplify pretty much all of those numbers right away, which is nice. Now there's no x's on the bottom, so I can't simplify the x's at all. So we're just going to keep that as is. So the x squared stays on top. Now with my y's, I can cancel these y's to the third, and then I can take away one of these y's, so I'm just left with a y on top. With my z's, both of the z's cancel, so all I have left now is an x squared and a y. You really have to keep track of your of what you're canceling, okay? Be careful. Sometimes we cross things out, we don't remember that we crossed them out. All right, so now if I multiply straight across, I'm going to get 18, and then the r squared times the r squared is r to the fourth, over 5 times 7 is 35, and then s to the third times s is s to the fourth. There's nothing I can simplify out of here, so we are done. A reminder, if I have anything in the exponent, like if I have a base a and it's to a number, we subtract those numbers, or basically we're just taking away what's left. So if I have a to the fifth over a to the third, I'm taking 5 minus 3, and I'm left with 2. So I just have a squared. If we had more on the bottom, so let's say I had a to the fifth on top and a to the seventh on the bottom, we're still subtracting, but we're going to have those 2. So if I took 5 away from the 7, I'd have 2 left. We still have to have those on the bottom since there's more on the bottom. So just keep that in mind. Okay, so now we're multiplying these together. And if you want to rewrite it, let's factor this polynomial first, okay? So I can factor that by the guess and check method, and I can do x minus 3 times x minus 3 because it's one of those perfect squared trinomials. I'm going to put it over 1, and then it's 2x times 6x minus 18. However, look at this 6x minus 18. You can pull a 6 out, so you're left with x minus 3. All right, before I go, I am going to cancel that x minus 3 with that x minus 3. I've still got 1 left. And I'm going to cancel this 2 with this 6, so 1 and 3. So now I have an x times x minus 3, because I've got an x here, over, I've got a 3 on the bottom. Sorry, let's just write the 3 in the middle. All right. You could leave it like this, or you could distribute back, so we get x squared minus 3x all over 3. And you're done. So just to review here, we factored this and stuck it over 1. This I pulled out a 6, and then I'm just canceling things that I can simplify to make life easier. Just remember, just as you can write an integer as a fraction, you can write any expression as a rational expression by just making the denominator 1, like I just did in that last one. Even though this was not a rational expression up here, I just put it over 1. So I can put anything over 1 if I want when I'm multiplying. There are 2 methods for simplifying rational expressions. We'll simplify first by dividing out common factors and then multiplying the remaining factors. You could also multiply everything out first and then simplify. I don't like to do this because I think it's more challenging. Like I said, you get bigger numbers. I like to simplify in the beginning before I multiply out. But either way, you get the same answer. Okay, so like what I'm saying here is we could multiply this by this first, but I think it's easier to factor and simplify. So let's factor this top 3a squared plus 6a. Well, I can pull out a 3a, and I'm left with a plus 2 over 12b squared times, I've got a 2b cubed on top. On the bottom here, I'm going to pull out a 3b, and I'm left with a plus 2. Now I'm just going to cancel everything that I possibly can. I see that these cancel because they're diagonal. I see that I can cancel this 3 with this 12. 3 goes into 3 1 times, 3 goes into 12 4 times. I see that I can take these b's away from here, but I'll still have 1 b left. Then I've got a b left on top, which will cancel with this b on the bottom. And then, even more confusing, so we've still got an a left here. I've got a 4 and a 2. This 2 can cancel with this 4, so all I'm left with is a over 2. Okay, if that's confusing, you can multiply straight across and then cancel. So for example, before I canceled everything here, I could have multiplied this 3a, so I would have had 3ab cubed times a plus 2 over 12b times 3b, so that would be, or 12b squared times 3b would be 36b cubed times a plus 2. And then this would cancel, these would cancel, and 3 would go into 36. Did I do that wrong? What did I originally have? Oh, this should have been, sorry, 3 times 2. It should have been a 6. And then this, did I originally have? What did I pull out? Maybe I did it wrong. I see what I did. Okay, so maybe it is better to multiply first, because this 6 and that will cancel with this, and I would have a 6 on here. So all I have is an a over 6. The reason I didn't get that down here is because I had a 2 and a 3 here that I should have multiplied together to get 6. So it can get really confusing. I guess, yeah, you just have to really keep track of what you're canceling. I think sometimes factoring and then multiplying might be easier if you're not going to get big numbers like here. That might help. If you can keep track of everything and not do what I did and forget that there was a 2 times a 3 here, then that would be okay. So again, you just really have to keep track of everything. If you're dividing rational expressions, the rules for dividing fractions are the same. You would just multiply by the reciprocal, like we did in the warm-up. So let's look at one here. So if I have 2 over g divided by g plus 4 over g plus 2, or g squared, I could rewrite that as 2 over g times g squared over g plus 4. Now, these would cancel with this, and I'd be left with 1g, so I'd have 2g over g plus 4, and I would be done. On this next one, if I want to rewrite it, I have 1 minus n squared over n times n squared minus 4n over n minus 1. So I just did the reciprocal. Okay, now we're going to factor. This top part here is one of those perfect square binomials. So I have 1 minus n times 1 plus n all over n times, this is, I can pull out an n, so I'm left with n minus 4. And on the bottom, I've just got n minus 1. Okay, well, let's look. I can cancel this. I cannot cancel this with this because they're not exactly the same. However, if I wanted to take a negative 1 out and rewrite it as negative 1 times n minus 1, leaving that other part the same, then we could cancel. I can rewrite this again. This would cancel as we set up here. Now these will cancel. So I'm left with negative 1 times 1 plus n times n minus 4. If I put this back into here, I can have now I would have a negative n minus 1 times n minus 4. We could FOIL this out to get back to a trinomial, and it would be negative n squared plus 3n plus 4. Okay, again, the big thing I think people get confused on is I have to take out a negative 1 here in order to flip this n minus 1 so it can cancel with this n minus 1. Okay, one more. Now, we know that technically I can put anything over 1, so in order to make this not division and to make it multiplication, we're going to flip so that we get 1 over 2x squared plus 6x. Now I can factor. So I'm going to rewrite it. 4x squared or y squared over y times, I'm going to factor the bottom. I'm going to pull out a 2x, and so then I have an x plus 3 left. Now, these y's will cancel. I'm left with one y. These x's will cancel, and this 2 I can take out. So now I've got 2 times 1, which is 2, over, I've just got an x plus 3. Oh, I had a y here, I forgot. See, again, keep track of everything you're doing. It can get tricky sometimes if you don't keep track. Sometimes I like to circle like this so I know not to forget about it, so that might help, just keeping track of everything. So, review, when you're dividing, you need to multiply by the reciprocal. You need to make sure that you factor so that you can cancel things out. You can only cancel when something is multiplied by something else. You can't cancel, let's see, for example, you can't just cancel like these x's with one of these x's. That's not allowed because there's a plus sign in the middle here. It has to be something multiplied by something else. So that's something you really want to be aware of. Okay, and we're done.